project titled A Multi-Scale Analysis of Micronutrient and Phytochemical Retention in 3D Printed Infant Food seeks to address a critical gap at the intersection of additive manufacturing and infant nutrition by ensuring that technological innovation does not compromise on nutritional integrity. While the 3D food printing market is on a trajectory to become a multi-billion-dollar industry, its scientific foundation lacks depth in a crucial area, which is nutritional safety for vulnerable populations. Current literature and commercial efforts are predominantly focused on sensory attributes and mechanical properties for adult applications. This, however, creates a significant void as post-processing processes can degrade sensitive micronutrients. Our research is positioned to fill this void by systematically investigating the impact of post-processing procedures such as heating and freeze-drying on the nutritional profile of infant-specific formulations. This slide outlines our research landscape. On the left, you can see established work including optimizing printing parameters, looking at consumer appeal, and a lot more. The center highlights our target, which is the unstudied nutritional impact of post-processing techniques on 3D printed infant foods. The right presents our methodological approach. We will empirically test how different treatments like heat versus microwave versus freeze drying and a lot more can affect key nutrient levels to close this knowledge gap.
To address this research gap, our project employs a multi-scale characterization strategy. The central premise is to establish clear correlations between the material's structure, chemical, and mechanical properties and its ultimate nutritional performance, specifically nutrient stability and bioaccessibility. This investigation is guided by a core material science principle, the process-structure-property relationship. We hypothesize that post-processing serves as the input, which alters key materials' properties. These alterations subsequently govern the final nutrient outcomes. To qualify these changes, our methodology employs target techniques. Microstructure evolution will be characterized by optical microscope and SEM. Chemical degradation will be accessed using FTIR and UV-VIS. Nanomechanical integrity will be mapped via AFM, and critically nutrient retention and release will precisely qualified using HPLC. In this slide, we can see each technique provides distinct insights. SEM reveals microstructural features that dictate bioaccessibility by controlling enzyme pathways. FTIR probes molecular level chemical degradation and identifies oxidative damage. UV-VIS monitors concentration loss of nutrients through absorbance changes. AFM correlates local mechanical properties with nutrient encapsulation mechanisms. HPLC will provide definitive quantification of nutrient retention and bioaccessibility. Through in-target analysis of these data sets, we will develop a predictive model that directly links processing parameters to nutritional efficiency.
Here is the plan. Overall, there are 4 stages. Stage 1, formulation. We create infant-safe, nutrient-balanced printable inks and pick the most promising ones. Stage 2, printing. We tune nozzle, speed, temperature, and layer height so prints extrude cleanly and hold their shape. Then set a clear go or no-go printability criteria. Stage 3, characterization. Leverage methods mentioned above to know more about the details. This links what we make and how we print to the structure and the properties we get. Stage 4, data analysis and design rules. We turn results into a practical design map, formulation ranges, and the rheology window that reliably produce printable infant-safe textures. For the impacts, there are overall 3 parts. So first one, a scientific framework for personalized 3D printed infant foods. Second, precision nutrition, dose, texture, and release tailored to infant needs. The third one is generalizable, a transferred method for elderly care, phagia diets, and other medical nutrition needs. To close, we measure, we map, and we personalize nutrition at scale, starting with infants, expanding to healthcare. Thank you.